Hello all, welcome to my channel Practical Engineering, Electrical and Networking. I hope all you are doing just great. In my first session, I taught you the basics of control panels. So, in today's session, I am going to teach you the types of signals which comes out of the PLC and goes to the PLC and their applications as well. So, before I start the session, I recommend you if you have any doubt in entire session, please post your doubts in the chat box. I'll try to resolve your all the questions in my next session. So let's begin with the session. At start, it is very important to know the PLC architecture. Okay, as you all know that the main component of the PLC consists of central processing unit, that is CPU, its power supply, then programming devices and input and output modules. The CPU is the brain of PLC and carried out the programming operations. So these operations are outputs are executed based upon the signals and data provided from the connected inputs. So what are those inputs and outputs, how they are worked, what voltage required and on what bits they are worked on, and what are the types we are going to learn. As you all know that any process in the world is automated by using the input devices and the output devices. Now, I'll teach you the type of input and output devices. There are basically two types of signal, that is analog and digital. Analog consists of analog input and analog output. Then digital is also the same format like a digital input and digital output. It may be a 16-bit, 32-bit, 8-bit DI card or DO cards. It means if we consider the DI card, then one signal is equal to 1 bit. Always remember these things. So the short form of digital input is DI. The digital input is a circuit designed to receive the binary signal transmitted from the industrial sensors and translate that input into the reliable logic signal for the PLC. Okay, in any industrial controller. So it is used in the PLC and motor drives to receive the 24-volt digital input from the field sensor and the switches. Okay, it means the digital signal is a signal that exists in one or two states, that is high and low, open or close, on or off. It may be a three senses, means any devices on the field. How we can know that it is active or it is on or off? So from this digital input, the digital input signal we can see on the DI card. So it shows on off status as well, open or close status. Okay, the digital input output devices is the hardware that sends and receives these digital signals. Okay, then DIO devices are usually built around the simple relays. To understand little bit more about the relays, we will move to the digital output. Before dive into the digital output, I clearly mention you or summary of the DI is it shows the on off signal or open or close signal on the PLC card, or it may be on the SCADA as well. Because of it, we can know the status of field devices or sensors. Now, what is digital output? The digital PLC output are the control circuit that use only the binary data, that is 1 and 0. Okay, to give the PLC CPU control over the field output devices. The digital PLC output is thus proceeds a binary control output from PLC to the field devices. It means it gives the 24-volt DC to the field devices in the form of relay. Okay, or through the relay output. It means when load comes, then load operate. If it is absent, the load will be off. It only indicate on and off status. The digital output are of three types, that is relay output, transistor output and triac output. We all aware about the relay output. The relay is used in the PLC. By using the relay, it drives the load. Relay having its mechanical contact. With the help of that, we drive AC or DC load. It is a benefit of relay. We can drive the AC or DC load. Okay, by using one PLC output, we get the 2 or 4, minimum 2 or maximum 4 and above, we get an relay output. So only one triggering signal is required from the PLC and we can get the minimum 2 or maximum 4 to 6 outputs in the form of relay or relay through the relay. and the major benefit is it can operate on the AC and DC as well. As each and every device has its pros and cons, such like that the PLC also causes have some cons. So the disadvantage of the relay output is that it is used for the slow switching applications because relay takes a time to energize the coil. Obviously, it having some mechanical contact, so after getting the triggered signal, it will take some time to energize its coil, as well as it takes a time to complete the contact, then for the coil to de-energize. Means it will take some time for few seconds to operate the output. So it is used for the slow switching applications. Just like that, the another output is transistor output. It is used in the PLC output used for the fast switching application. Okay, this advantage is overcome in the transistorized output. Only it is used for the DC application. The thing is, it is only used for the DC applications or the DC devices which is operate on the DC supply. But when we use the transistor type PLC output, it has some leakage current when load is connected to the output. Okay, then the disadvantage of the transistor is when it is connected to the output, it has some leakage current, so it is a disadvantage. But the advantage is it is used for the fast switching application. So the third one is triac output PLC. It is only run on the AC load and it is used in the fast running application. Okay, as transistor is used for the only DC application, just like that the triac output is only used for the AC applications. So the summary of digital output is nothing but the switch that a PLC operate to turn on or off the output devices. It is controlled by the logic written inside of the PLC. It means digital output is used to turn on and off the field devices by using its logic, and digital input is it shows the status of field devices or sensors on the PLC. So you all are cleared with the digital input and digital output. Now let's dive into the analog input. Then the input instrumentation, it is used in the control system, used in the instrumentation as well. Instrumentation devices, it generally supports the 4 to 20 milliampere signals. Okay, why 4 to 20 milliampere signal is used? Because previously 0 to 20 milliampere is used, but the disadvantage of that 0 to 20 milliamps is whether device is connected or not, we cannot come to know through this 0. It means why 4 to 20 milliampere output is preferred over 0 to 20 milliampere is this arrangement differentiates between the failure of the devices and no input to the devices. That is, any output less than 4 milliampere is considered to be a failure of the devices. However, these devices call for the auxiliary power supply support to the function, while some of them are the self-powered or deriving the power of their internal functioning from the physical signal input. Example, electrical transducer. There are various devices such as pressure transmitter, temperature transmitter, level transmitter, analyzer, transmitter. These are the example of analog input. That means it get the output from the field via this sensors like analyzer, transmitter over the 3 core or the 2 core cable. It means the 4 to 20 signal comes from the field devices. Field devices as I mentioned earlier, like PT, TT, that is pressure transmitter, temperature transmitter. It directly give to 3 core or 2 core cable to TB, that is terminals, to the AI card, that is in the form of 4 to 20 milliampere. Now let's move towards the analog input summary. So what you have understand is the analog signals are the fundamental pieces of information upon which the control system operates to determine further derived information or control parameter according to which the TG can best be operated. It means it takes the information in the form of 4 to 20 milliampere signals from the field devices as sensors and give to the analog input cards. As simple as that. Most simple example of the analog input is the wall operation. It means the 4 to 20 signal indicate that how much wall is opened. That is 4 to 20. In between that numbers, it will come to know that what is the condition of its wall, whether it is open or fully operated, partially operated or closed. Now, let's dive to the analog output signal. As I said earlier, the wall operation. It means wall opening and closing condition is shown by the 4 to 20 signal, which is in the form of analog output. Okay. Now, the 4 to 20 is most common analog output signal is the 4 to 20 milliampere current output. This is universal signal that could be related to the temperature, pressure, analytical measurements like pH or conductivity. In most cases, the 24-volt DC supply powers the current output signal. Okay, means as we know that one device, it is powered up with a 24-volt DC signal, which is power to the input, but its signal is 4 to 20 milliampere or 0 to 20 or 10 volts as well. The transmitter converts, what transmitter do is it converts a major variable into 4 to 20 signal current output, where 4 milliampere is equal to 0 and 20 milliampere is equal to 100%. It means, as I said earlier, the wall example is very simple and very understandable. If the wall is closes, that is 0%, what PLC output will show the 4 milliampere. If it show the 20 milliampere, then wall is 100% opened. There are multiple wiring schematic for the transmitter as well. As you have you must have gone through the two wire, three wire concepts. So two wire means what? The current and voltage on the same, that is plus minus wires. Normally it is referred to the loop powered. That means two wire. There are two wires. Three wire means what? A common 24-volt DC power supply is used for both the transmitter sensors and 4 to 20 milliampere current signals. Means 24-volt DC power is common. Then what is 4 wire? There is 4 wire as well. Separate 24-volt DC power supply are used. Okay. It means the 4 to 20 signal and power is same, which is called as 3 wire or 2 wire. If power supply 2 wire for the power supply is different and signal cables are different, then total wires are 4. So it is called as a 4 wire as well. It is not only up to the 4 to 20 milliampere. Some devices are operate on 0 to 10 volt DC as well, or 1 to 5 volt DC. So DC voltage outputs are also commonly used as a universal signal for process control. As we go in detail into the instrumentation or process industries, we can come to know that 0 to 10 volt is also used for the analog. For example, 0 to 10 volt DC is prevalent in building control, that is HVAC application. Thus, may have some crossover into the industrial control. When in doubt, check the specification of your devices to learn about its voltage output range. Okay, every devices has some specifications. Some are operated on the DC, some are operated on the AC as per their application. Now, what is the summary of analog output? The analog output is predominantly used to control actuators, valves and motors in the industrial environment. What it does is it controls the field devices in the form of 4 to 20 milliampere signal or 0 to 10 as per their requirement. The standard analog output ranges from, as we know, that 5 volt, 10 volt, 0 to 10 volt, 4 to 20 milliampere and 20 milliampere. Now let's have a quick look over DI, DO, AI and AO, that is analog signals and digital signals. Okay, first of all I am showing you the digital input. The digital inputs are binary input. It's a summary, so be careful with this summary, and it is very important for your future. The digital inputs are binary input, that is 0 or 1, that is applied to the PLC. Binary inputs are basically voltage varying from 5 volt to 230 volt depending upon the type of cards used. Okay, different cards having the different current capacity, which is varies from 5 volt to 230 volt depending upon the type of card. Okay, in simple words, any push button, switches or sensor produces the digital input to the PLC. Keep in mind, digital inputs are used to check the status of the devices, whether it is on, off, for input model of 24 volt DC, 0 volt DC act as a off state, that is binary 0, and 24 volt DC act as on, that is state binary 1. Okay, now what is digital output? Digital outputs are binary output 0 or 1. Okay, digital means it, by the digital name itself indicates 0 or 1 from the PLC. It is proceed the control output from PLC to field. What it will do is it proceed the output from PLC to field. As it is named, it is digital output. So it is used to on and off the piece of field equipments. DO is like the contact of relay. When it is programmed condition are satisfied, the contacts are closed. DO can be used to operate the solenoid valves, relays, indicating lamps, or command to any other devices. These are the devices used for the digital output as well. Now, what is analog input? That is AI. Analog input is continuous input from the field to the PLC. Unlike digital signals, it is not constant voltage signal. Okay, as we know that the digital is constant, but it is not a constant signal, constant voltage signal. It can vary depending upon the field condition. What is the field condition? It is depend upon the field condition. It is totally different from that of the digital output. The common use analog signals are 4 to 20 signal and 0 to 10 volt DC. It is not only operated on the 4 to 20, it will be operated on the 0 to 10 volt DC as well. Depending upon the field condition, the input signal can vary between 4 to 20 and 0 to 10 volt DC. For example, if you are monitoring the pressure of water flowing through the pipe using the pressure transmitter of range 0 to 10 bar, we can say, okay, the pressure is always measured in the bars 0 to 10 bar. The transmitter will give a signal between 0 to 10 volt proportional to that of the pressure in the pipe. Okay, means 0 to 10 volt is equal to 0 to 10. If my bar pressure is 5 bar, then what it will indicate? In between 0 to 10 volt, it will indicate 5 volt, or whatever the programming has been done into that programming, or whatever the parameters are set. Okay, then what is analog output? The analog output is continuous output from PLC to the field devices. As a digital output, it gives from PLC to field, just like that the analog output is from PLC to field devices. For example, if you have a variable frequency drive and you want to give a speed reference, as we know that the VFD is operated depending upon the frequencies. It is not a continuous whatever we give to it. Whatever the load is connected, we can adjust the frequency by using the AO as well. Okay, if you want to give a speed reference signal to it can be used the analog output. Okay, the speed can be varied by using the analog output in the form of 4 to 20. When you see the VFD na, then there is a parameters like 0 to 10 volt selection is there, 0 to 10 volt or 4 to 20 milliampere. So as per our requirement, we set that parameter, and if I give the 12 milliamps signal, then it will operate as accordingly the speed. It will not operate on the full speed, but partially we can increase. Otherwise, if you are measuring the pressure by using the analog input, it is explained above when I explained it earlier, and you would like to display it on the analog meter, you can use the analog output of the PLC. So from this summary, we have differentiated the analog and digital signal. Okay, now sometimes you may get confused in between DI and AI. So I explained earlier, the digital input and analog inputs are the data collected from the field. They both are the data collecting, but in the form of they're in the different form. The digital input is binary in the nature, either it can be a on or off, it can be a off. Okay, or either it can be a 0 volt or it can be a 24 volt based on the type of IO modules. IO module is also very important. Or depending upon the sensors and switches, etc. Are the examples of digital input. What is the examples of digital input? Always keep in mind switches and sensors. The analog input is the time varying signal. It is a time varying, and it can be vary between the 0 to 10 volt and 0 to 20 milliampere or 4 to 20 milliampere based on the design. Transducer are the example of analog input devices. Now, the difference between digital output and analog output. The digital output is the binary in a nature. Either it can be on or it can be off. Either it can be a 0 volt or it can be a 24 volt based upon the type of IO module is used. Analog input is a time varying signal. Both are doing the same functioning but depending upon their signal types or IO modules. It can varying between the 0 to 10 volt on 0 or 4 to 20 milliampere based on their design. I hope this session is helpful for you guys and you can easily differentiate the analog and digital signals as per their requirement and their respective parameters. I have also covered the examples of the different signal like DI, AI, DO and AO. Okay, thanks for listening me and I will come with exciting topic in my next session. Thank you.